In this video, we're going to discuss the concavity and vertex of parabolas. So a quadratic function always has a graph that has a specific shape to it. It's called a parabola. Any linear or nonlinear function will have a bend to it. And we'll generally call that concavity. It describes how the graph opens. If it's concave up, that means the graph will open up. If it's concave down, that means the graph will open down. So the quadratic functions that we're showing you right here are all concave up. And if you look at them, that just means they're kind of opening up. Kind of the bottom of the hill, if you will. The other ones down there are concave down, and these graphs open down. Go figure. That's where the name comes from. So as a quick check, we'll just kind of classify these real quick. And I'm just going to write the word up or down. I'm not going to write concave up or concave down, just to save a little bit of time. This first one here looks like it does open down, so that would be a down graph. And this one is up, and that's an up, and up, down, and I think at that point you kind of get the idea. It's basically how the graph will show. We can also tell this from the equation of the graph, and it has to do with this number that's in front. Let's look at all these equations right here. They're all concave up. What I'm looking for is this number that's in front of x squared. We call that a coefficient, or if it's in front of the quantity, x whatever squared. Now the one that's a little bit tricky is that one in the middle at the top. And that one has a coefficient of 1. It's a 1x squared. All right. So the other ones down here all have negatives in front. And so they're going to open down. And again, that's the distinction between concave up or concave down with the equation. So again, I'm just going to write up or down for these. We want to classify each quadratic function as concave up or concave down. So again, I'm looking at the number in front of x squared. That's a negative, so that's a down graph. The number in front of x squared is positive, so that's an up graph. Let's just jump down to this one here. That's a positive in front. That's an up graph. Negative 1 in front. That's a down graph. And one more. How about, I don't know, this one here. There's a 2 in front. So that's an up graph. That number in front of the parentheses will tell you if it's concave up or concave down. So the other part of what we're looking at today is called the vertex of a parabola. The vertex of the parabola is either going to be at the high point or the low point of the graph, and it's the ordered pair. So for instance, on these graphs here, we have a vertex at this point down here, which is at 0, 0. This point here, which is at 0, negative 1. Here at negative 2, 1. Or the down graphs of 2, 0, 4, 15, 0, 2, and so on and so forth. So we're asked to find the vertex of these graphs. We're just looking again for that either high point or low point. So if I look over, it's at 2, 3. That would be my vertex. This one would be at 4, 2. And that's at a low point. Number 4, we're at this point here, which is 1, 0. At this point here, we're at 2, 0, and so on. All right, so again, vertex is usually just the high point or the low point of the graph. So in activity 2b, then, we're actually going to take that information that we have, and we're going to pick out the concavity, not only, but we're also going to pick out the vertex of the graph from vertex form of the equation. So let's explore this a little bit more in depth. And really what we want to think about is, this is very much like when we solved equations that look like this. And in that form, we're looking at what's called a point-slope form of the equation. So we're going to take our y-coordinate, whatever it is, and we're going to take y and subtract off whatever our y-coordinate is. We're going to use our slope and then multiply that by x minus whatever our x-coordinate is. The formula for a vertex form of an equation is kind of the same thing. F of x generally can be used to represent the vertical output of a function. In a lot of cases, that's going to be a y-coordinate. So if I wanted to, I could rearrange this a little bit to make it look like this. And I'm going to treat this as a y. No, it's not a y necessarily. I'm just going to call it a y for ease. And if I bring this k over, now it has a ton of similarities to that point-slope form of the equation. What we're looking to do is pick out the concavity and the vertex just from the equation, not having a graph or anything. We want to be able to look at the equation and figure that out. Well, that a value, just like it did on a previous activity just moments ago, will tell us if the graph opens up or down. So this number will tell us concavity. I'm going to abbreviate con for concavity. And the other part that we're looking for is how do we find the vertex? Well, the vertex is going to be given by this coordinate and this coordinate. So whatever is being subtracted from x tells us our x-coordinate. And then whatever's being added at the end there tells us our y-coordinate. Again, it's this part's going to change signs, this part is not. Looking at the examples here, it works out the same way. The ones that are going to be kind of tricky, I think, are this one right here and this one. And the reason they're tricky is they don't quite fit that form perfectly. If you look at the one for D, we really don't have anything added at the end. And that's why there's a 0 there, because nothing is being added to that quantity that's squared. Looking at g of x, nothing is inside the parentheses that's being squared. So it's really x minus 0, or plus 0 if you want to. It doesn't really change the meaning of it. So let's pick out some information here from a couple equations just randomly chosen. All right, let's do an easy one first. So number one here, we want to pick out the vertex and the concavity. So because we have a plus 3 here, that means we had to subtract the negative 3. So my x-coordinate is negative 3, and my y-coordinate is just that number right there. Concavity is told by the number in front of the parentheses, that's that negative 2. So that graph will be concave. Whoop, I got it backwards. Negative number there, that will be concave and down. All right, what about this one here? So our vertex looks like we are subtracting 4, so my x-coordinate would be 4, and my y-coordinate will be this guy right here, so it's 1. And the concavity is based on the number that's in front. The number in front of that parentheses is 1. Since it's a positive number, it's concave up. In number 5, our vertex, the x-coordinate is going to be kind of difficult to pick out. The y-coordinate is specifically told us it's 3. But the x-coordinate is whatever's in parentheses. Oh, there's no parentheses. So we're really not adding or subtracting anything from that x value. We're going to treat this as a 0. And then our concavity is told to us by this number here, that negative 2. Tells us it's concave. Down. And then finally, number 9, it seems like there's a lot of information missing, but this is actually a really good graph to reference. There's pretty much nothing being done to x other than squaring it. So there's no kind of movement left or right. So what's with the x is a 0, and then what's following that is also a 0. And a concavity, we have a number 1 in front, so that's concave up. So again, that's the vertex form of a parabola, and we use that to pick out the vertex and also the concavity to figure out, does it open up or does it open down?